Okay. All right, so starter question. What did the word consistent mean when we learned about that in 3.2? They should be coming. There we go.
Well, I didn't know what to do with them, so I put them up there.
I see. Fair enough. Consistent, what does that mean? When we're talking about systems of equations.
It follows the pattern.
Slightly disappointing, I must say. Vocabulary word, we haven't learned a ton of vocabulary, but that's one of them you want to know. The word consistent means the system has a solution. So consistent means has a solution, or it has an answer. Then what does the word inconsistent, and please get this one right. Okay, this one means there's no solution. Okay? So consistent means it has a solution, inconsistent means it doesn't have a solution. Now, when we were graphing two lines and they crossed, they just had one solution. Okay? If they were right on top of each other, they had a bunch of solutions. Okay? And you had a few problems like that on your assignment. Maybe you wrote the answer in set builder notation. That was called a consistent dependent system because the answers for one depended on the answers for another. And then sometimes we had lines that were parallel. Okay? So we've got cross, there's one answer. Have them right on top of each other, infinitely many solutions. The way we'd say this is if this was like y equals 2x plus 3, we'd say it's the set of x's and y's such that y is equal to 2x plus 3. Put that in a set and we're all set to go, so to speak. Okay, then if they're parallel, what do we say there? We're trying to find the point where the lines cross. We say no solution. Okay? There's no point that would work in both of them at the same time. Well, when we're dealing with two equations and two unknowns, okay, like x's and y's, it's translated as the point where the lines cross. Okay? If we're doing this with three equations and three unknowns, you'd have to graph not lines, but you'd have to graph planes in three-dimensional space. Now, luckily, we don't have to graph planes, and we don't have to see what they look like in three-dimensional space. But we can look at some pictures and see what happens here. So I've got a green plane. Maybe you can look up here. I've got a green plane, a blue plane, and a gray one. Consistent or inconsistent? Consistent, because they cross in one single point. Okay? Here's the blue plane, gray plane, and green plane. Consistent or inconsistent? Okay, this is consistent, but we're going to have an infinite number of answers to this because they cross in a whole line. Okay? How about this? Inconsistent because they don't cross at all. And how about this? That one's also inconsistent. My gosh, it helps that the answers are right below. Amazing. Okay? Even though this looks like there ought to be some answers, remember what we're doing. We're solving the system. The word is we're solving it simultaneously. We want something that works in all three of the equations at the same time. So there's a point that's on all three of the planes, so it would work in all three equations. There are a bunch of points that are on all three of the planes. Nothing in common here. Nothing in common with all three. There's only something in common with two of them at a time. There's nothing where they all three intersect. Any questions there? Okay. So on your paper, it's got a description of how to do these. This is taken right from the textbook. It's very similar to how we solved a 2x2 system, so it's got 6 steps, so it's actually not that bad. Okay, and it's not like you have to memorize each one word for word and then go through it step by step. So it says write all equations in the standard form: x's, y's, z's, and then a number on the other side. So we want all the variables collected on the left side, a number on the right side. Clear any decimals or fractions. Okay, you saw some problems like that in Math Excel when we were in 3.2. If you've got decimals or fractions, usually those are a pain to work with. Okay? Choose a variable to eliminate. Okay? Take 2 of the equations, eliminate that variable, and then the next step it says use a different pair of equations. Okay? That's important. You've got to use a different pair of equations when you're doing that. What you're going to end up with after you get to step 4 is you're going to have a 2x2 system. You're going to have 2 equations with 2 variables, and at that point, you should know what to do with that because then we're back to a problem from 3.2. Okay? And then again, we normally finish solving these. Whether you do substitution or elimination, we always end up using substitution to find the last couple, because you find an answer, plug back in and find the ones that you're missing, okay? Now, I'd like you to, I wrote this down. I'd like you to pay careful attention to this. There are a couple sentences here. We're actually going to read these. So Jared, would you read that sentence right there?
Okay. Your best bet to avoid frustration is to do each step very carefully.
Okay. So if you try and rush through these, you're going to make mistakes. So go through nice and slow and be careful. Okay? Elaine, what's that next sentence say?
If you make one mistake, you will not get the correct answer.
Okay. You might go through and you might do 50 calculations. If you screw up one of those, your answer will be wrong. Okay? Emily, what's this next sentence there?
These steps are not hard, but there are a lot of them.
There might be 50 steps 50 little calculations, like 2 plus 2, 5 minus 7. Okay? You might have to do problems like that 50 times in one problem. Okay? They're not hard. They just take a little time, and you've got to be careful with those. Okay? The next one I'm going to read, it says, when writing down the system, it's important to write neatly. Keep each part of the equation lined up vertically. So you've got the advantage of, take a look at this one right here. It's the same one that's on your paper. It's all lined up. I've got the x's lined up, the y's lined up, the z's lined up, the equals lined up, and then the number on the other side lined up. Okay? You don't have this one on your paper, do you? Okay, you're going to in just a second. So I'm going to zoom in on this one, and we're going to solve this problem right here. Okay? So here's how we solve this. We pick a variable to eliminate. We pick a variable to get rid of. Now let's go through. Do I want to get rid of the x's? Do I want to get rid of the y's? Or do I want to get rid of the z's? And usually it doesn't matter. You just want to pick one that's the easiest. Okay? Amelia. Okay. Amelia says the y's. Why do you say get rid of the y's? Okay, this is equation number 1 and this is equation number 3. That's the only reason those are there. If we just take the first and the third equation and add them together, I get this. I get 3x. How many y's? Okay, if I'm adding this equation to this equation, I have no y's. Okay, so the y's are gone. Okay, and then what do I get with the z's? Minus a z, and that's the 4 minus 1, that's going to be 3. Everybody good there? Okay, now, Amelia said, hey, let's get rid of the y's. I'm fine with that. We would have had to change signs on the x's in order to get rid of one of them, because remember, to eliminate, they've got to be the same number, same coefficient, but opposite signs. What else would have worked, Zach?
Well, I actually have a question. So, sorry.
You're fine. Go ahead.
Oh yeah, so when you're trying to eliminate, you only eliminate 2 at a time, not all 3 at once?
Right. You're going to take 2 equations, eliminate one of the variables, and then we're going to pick another 2 equations and eliminate the same variable. Okay? Okay. Does somebody have another choice for what variable we could have started eliminating with? Chris? The z's. Because look, those are the same, but opposite signs. So either the z's or the y's I think would be the easiest to get rid of. We've already started getting rid of the y's, so let's continue with that. So here's the key. We took the first and the third equations, put them together, got rid of the y's. You have to take a different pair of equations, so either 1 and 2 or 2 and 3, put those together and get rid of the same variable. Don't say, oh, he said we could get rid of the z's and expect that that's going to get anywhere with you. So we've already started getting rid of the y's. Let's continue getting rid of the y's. Everybody with me? So do you want to use equation 1 and 2 or equation 2 and 3 to get rid of the y's? 1 and 2. Can somebody tell me why 1 and 2 probably would be the best way to go here? Why is 1 and 2 better than 2 and 3? Yes. You don't have to change the sign, okay? All we have to do is make this a positive 2 and we can get rid of it. Here we'd have to make this a 2 and make it positive, so we'd have to change the sign and the number. Everybody with me? Okay, so I'm going to do this in red. I'm going to take equation 1 and 2. I'm going to take equation 1 and I'm going to multiply it by 2. And here's what I get. I'm going to write this off to the side. So I'm going to get 2x, 2y, to z equals 8. I'm going to rewrite this one, and again, there's no getting around some of these steps. You just got to be careful. X minus 2y minus z equals 1. And I'm going to put those together. This equation right here is the same as equation 2. All I did is rewrite it. This first equation is like a copy. It's an alternate form of equation 1, but it's still a true equation because I did the same to both sides. Any questions? Okay, let's put them together. I have 3 x's. Look at that. No y's. Plus a z equals, that's going to be a 9. Okay, are there any questions? Because that's the hard part. If you can do that, that's the hard part. The rest is pretty easy. Because take a look at what I've got here. I have an equation 3x minus z equals 3. And I have an equation 3x plus z equals 9. So I wrote this one here, and I wrote that one there. Do you know how to do this? Isn't this from 3.2? I mean, at this point, if you can eliminate, eliminate. If you can substitute, substitute. But my gosh, what's this one set up for? Elimination. Look at this. I can just add these together. This is going to be 6x. This is going to be 12. So that means x equals 2. Okay? All right. Any questions there? Okay, I need everybody's attention. How many variables do we have to figure out on this problem? 3. We have to figure out 3 altogether. How many have we found? 1. So are we a third of the way done?
Yes.
Okay, let me rephrase. Are we a third of the way done with the work?
No.
No, actually, we're probably 70 or 80% of the way done with the work. Because once you find 1, take a good look here. Once I know what x is, wherever there's an x anywhere on this problem, I can put what? I can put a 2. So everybody watch, please. Tyler's going to tell us what to do, right?
Yeah. You could just plug it into the 3x plus z equals 9.
Okay. So he's suggesting plug it into this one right here. Now, could I plug it into this one? Sure. This one? Yeah, that's just the copy here. These are just copies. Could I plug it into either of these? Or any of these? Yes, I could, but how many variables would be left if I plugged it into any one of these up here? 2, and I don't want that. The nice thing about this is there's only one other variable in the problem, so let's see what we get. 3 times 2, and I am going to plug in parentheses because that's just a good habit. That's going to be 6 plus z equals 9, so that means z equals 3. Now, once I know z, what can I do with that?
Plug it in as well.
Very good. I'm going to come up here and I'm just going to kind of work my way back up the ladder. Okay, these only had 2 variables, so if I plugged in an x, I could find the z. I now know x and z. Let's go back to the original ones up here. Of 1, 2, or 3, which one would be the easiest to plug into?
1.
Definitely 1. So I'm going to take this, I'm going to put a 3 right there. I'm going to take this, I'm going to put a 2 right here. So if the equation was x plus y plus z equals 4, and I know x is 2, I don't know what y is, but I know z is 3, and that's supposed to equal 4. Let's see what I get here. 2 plus y plus 3, and I'm showing way too much work, right? There we go. Any questions? Are you sure? Okay, if when we were writing down the solution to a 2x2 system, we wrote down ordered pairs, we're going to write down ordered triples. They're x, y, z triples. So the answer on this one is 2, comma, -1, comma, 3, and that right there is it. Okay, don't just leave them like this. You should write them down as an ordered triple. Okay, are there any questions? Sure. Okay, now here's what I want you to do. You're going to copy this one down, but here's how we like to copy them down. Write down the row So you're going to write down 4x minus 2y minus 3z equals 5. I mean, we just naturally write them down in rows, in equations. Minus 8x minus y plus z equals negative 5. And then 2x plus y plus 2z, whoops, plus 2z equals 5. Now, I'm going to erase this in just a second, but I'm just kind of demonstrating here. Now, before you do any work, because you're going to do this when you do it on MathXL, you're going to copy it down from the computer screen, just like the screen up here, onto your piece of paper, and then you're going to start doing the work. If you write them down in rows, now notice how I kept these nice and neat and organized? See how the x's are all lined up, the y's are all lined up, and the z's are all lined up? Okay, I write really sloppy, but at least here I line this stuff up. Okay, let's double check. Should the first column, if you will, should it be a 4, a negative 8, and a 2? 4, negative 8, and 2. We got that right. Negative 2, negative 1, and 1. Negative 2, negative 1, and 1. Got that. Negative 3, 1, and 2. Negative 3, 1, and 2. Good there. And then I've got a 5, a negative 5, and a 5. So do I have it written down correctly? I do. Now I can do the work. Okay, are there any questions? Okay, if you're sloppy, you're going to pay for it because you're going to end up making mistakes. Okay? Again, nothing's more frustrating than going through and doing all of these calculations and figuring out, oh crap, I added when I should have subtracted. Okay? All right. So let's take a good look at this. What variable do you think would be the easiest to get rid of? Yeah, let's take some time. These aren't too bad. Whoa, look at that. The y will go away right now. Okay? So let's take equation 2 and equation 3 and let's add those together. So if I do that, I end up with negative 6x, again nice and neat, plus 3z equals 0. Now if I put 2 and 3 together, I have to do some other pair of equations. So my choices now are, I can either do 1 and 2 or 1 and 3. Which one do you want to do? 1 and 3. For the same reason as last time, right? Because all I have to do is multiply this one by a 2. So I've got 4x minus 2y minus 3z. See how many times you have to write these down? You've got to be really careful. 4x plus 2y plus 4z equals, let's see, that's a 10? No? Yeah, that's a 10, right? Put them together. Okay, watch. Watch. Okay. I'm going to save myself a little bit of work. I'm going to add these together and I'm going to put it over here. So this is an 8x. No y's. That's exactly what we want. I put those together there. I get a plus z. And over here I have a 15. Are there any questions? So I've saved myself a little bit of writing. Okay. And what variable do you want to eliminate? Let's get rid of the z. So I'm going to multiply this one by, what kind of 3? Got to multiply by a negative 3. So that's going to give me negative 6x plus 3z equals 0. Negative 24x minus 3z equals, let's see, this is negative 45. Is that right? Add them together. Ooh, this hurts. Dang it. What do we have? We have a fraction. I'm going to divide by negative 30. This means x is equal to, let's see, what goes into 45 and 15 evenly? 5 does. 15's even bigger. 15 goes in there 3 times, and it goes in here twice. So there is what x is. They're not all pretty. Okay, once we know what x is, we can come back here and we can say, well, let's see. I can plug this into, well, it doesn't really, well, let's see. Gosh, if we plug into this red one right here, what if I plug into that one right there? That's going to be 8 times 3/2. Plug in parentheses, please. Plus z equals 15. If there's a fraction in the problem, you might as well think of everything as a fraction. So let's put 8 over 1. And I'm not going to multiply these and get 24 over 2. I'm going to think this way. I can cross cancel the 8 with the 2. This is now a 4. So this is 12 plus z equals 15. Well, that's good news because that means z equals 3. So now I have 2 of the variables. I know what, let's undo that. I know what z is and I know what x is. Once I know what z and x are, I'm going to come back up here and I'm going to pick one of the original equations. That's usually best to plug into to find y. Now, do you want to plug into equation 1, equation 2, or equation 3? 3. Smaller numbers, right? And fewer negatives. Smaller numbers and fewer negatives, we're probably going to make less mistakes. So 2x, that's 3 halves, plus y, plus 2 times 3 equals 5. So this is, what is 2 times 3 halves?
3.
2 over 1, cancel the 2's, we end up with 3 plus y plus 6 equals 5. Y plus 9 equals 5. Move that over by subtracting, and we end up with y equals -4. So even though the first one worked out to be a fraction, still wasn't too bad to solve. Am I done?
No.
3 halves, -4, 3. There is our system, or our solution to our system of equations. Now, are there any questions there? Okay, that's how you solve a 3x3 system, 3 equations, 3 unknowns, or a system in 3 variables as it's called sometimes. Okay, are there any questions? All right, flip the page over. Okay, and I do just have that page there. They're actually, so you're missing problem number 10 also, right? Okay, we'll copy that down in just a second. Problem number 7, similar to some problems you have on your assignment. Determine whether that point is a solution to this system. How do you check to see whether or not it's a solution to the system of equations? You just plug it in, right? So let's go ahead and plug this in. How will we know if it is a solution? All 3 will be true equations. It will work in all 3. What if it doesn't work in one of them? Then we say no, okay? It's got to work in all 3 of them. So this is going to be 2 minus 1 minus 2 times minus 2. That's going to be plus 4 equals 5. That's good. So that's a yes. This is going to be 4 plus 1 plus 2 equals 7. That's a yes. That's going to be minus 2. Again, how am I doing that? I'm just thinking I plug them in parentheses. We doing okay? And this is going to be a minus 2. It's going to be a plus 2. See how easy it is to make a mistake? And then we're going to plug in a negative 2. This is going to be a plus 6. So that's supposed to equal 6. The answer there is yes, because it worked in all 3. Yes, it is a solution. Okay? All right. Any questions? Okay, let's take a look at this one. What variable would be the easiest to get rid of?
Z or X.
X or Z, they're both pretty easy. Let's take equation 1 and add it to equation number 3. Let's just combine those. So if I do equation 1 and equation 3, put those together, I get no X's. Holy cow, I get a Y, no Z's, and what's over here? A 1. Well, that's great. That's really nice. Okay? Here's the interesting thing about this. Even though the answer dropped out, we still have a fair amount of work to do. It's not as simple as the other ones, because remember what we don't have at this point. What we don't have is what we had above. Once we got here, we just took this and we plugged it in there. And we found what Z was. We don't have another equation with only one other variable. We don't have an equation with just Y and one other variable. So in order to solve this one, guess what we have to do? We've got to take this and we've got to plug it into at least 2 of these equations. Okay? So let's plug it into the first one. So this would be x minus 1 minus z equals 0. So that's this guy right here. And let's plug it into, let's see, do you want to use the second or the third one?
We have to use the second.
Oh, trick question. Amelia, would you say that again?
We have to use the second.
Why do we have to use the second one?
Use 1 and 3.
Okay, listen very carefully. Because you can do something that's technically correct and just spin your wheels here. How did we make this one right here? What two equations did we use? We used 1 and 3, right? We already used this combination here. So I wouldn't want to plug in and then use a smaller combination of 1 and 3. I've got to use, if I've already plugged into 1, I've got to use 1 and 2. Or I could have plugged into 2 and 3. Okay, but let's plug into this guy right here. So if I plug that in there, I get 2x. That's going to be minus 3 plus 2z equals 7. Now, does everybody understand how we got those two equations right here? Does everyone know what to do from here on out? Because there's something weird about these two. What's weird about them? Okay, there are no y's, which doesn't really bother us, but what should bother us is, look, they've got plain old numbers sitting in between the variables. You want variables on one side, numbers on the other. So I'm going to rewrite this as x minus z equals 1, and I'm going to write the other one as 2x plus 2z equals, let's see, if I move that to the other side, that would be adding 3, so this is going to be a 10. Now, are there any questions about that? And once you get to here, do you know what to do? Okay, from here on out, it's pretty darn easy, right? I'm going to multiply the first one by 2. That's going to be 2x minus 2z equals 2. That's going to give me 4x equals, that's a 12. So I get x equals 3. And once I have that, piece of cake. Plug back in, find the z. I've got x, y, and z, and I'm done. Do I need to finish this? Does everybody understand? Any questions? Okay, because I want to move on so we can finish the last couple. Sure? Okay, can I slide this over? Everybody done writing what's on here? Okay, so now I want you to write down number 10, and I want you to write it down nice and neat. Make sure you have it written down correctly, because I'm not going to double check. I've already got it right here on the screen. Make sure you've got it nice and neat, all lined up vertically. And then in about 30 seconds, I'm going to ask, what do you want to do first? So the first thing you have to do is figure out which variable you want to eliminate. Okay, make sure you wrote it down correctly, and here we go. Do you want to get rid of an x, a y, or a z?
I want to do 1 and 3.
And somebody tell me why that's the one you want to get rid of. Zach.
Well, I want to get rid of the x just because it's kind of easier to do like the long route instead of getting the answer straight out. So I would do 1 and 3 and get rid of the x
Okay.
instead of getting rid of 2 variables at once.
So Zach wants to go the long way and get rid of the x, even though, what happens right here? What happens with 1 and 2?
Y and Z.
You figure out
Okay.
what x was.
So if this is 1 and this is 2 and this is 3, if we put 1 and 2 together, remember, once you've used that combination, you're done with it. Okay? Zach would rather get rid of the x's, okay, and then go that route, rather than immediately figuring out what x is. And I'm fine with that.
Just because you then have the smaller.
Exactly. Exactly. Okay? So, is everybody okay if we go Zach's route? Because we already did one like what would happen here. So on this one, if we did that, we'd get 3x equals 3. So immediately you know x is equal to 1. Right? Okay. Let's eliminate a different variable. Okay? So let's ignore that stuff right there. Let's eliminate an x. I'm going to take 1 and 3 and add them together. That's going to give me no x's. That's going to give me 6y's minus 4z and a 2. If I did 1 and 3 and put those together, I've got to have some other combination, either 1 and 2 or 2 and 3. Which one do you want to do? I would say 2 and 3. Because on 2 and 3, all I have to do is multiply this by 2, and that I don't have to change signs. I just have to multiply it by something. So this is going to give me, I'm going to write it down over here, 2x minus y plus z equals 3. And I get minus 2x, that's going to go away. I get plus 10y, that's fine. And then I get a minus 6z equals 4. Again, lots of little arithmetic problems here. If you make one silly mistake, you're done for. I'm going to write this line. Am I going to write the new equation underneath here or somewhere else? Over here, because I have no x's. I've got, let's see, this is 9y. This is going to be minus 5z, and that would equal 7. So now I'm set up over here. I want to eliminate one of the variables. What's not so nice about this one at this point? Yeah, you got pretty big numbers. That's one thing. What else?
Not turn out even.
You have to multiply both of them. There's no changing one into the other. You've got to change them both. So I've got a choice of making 54s out of these. That would be the smallest thing they go. Well, let's see. No, not even 54. 36 would work? Well, wait a minute. Why would I bother with 54 or 36 when they both go into 18? Least common multiple. Okay? Use the smallest numbers possible. So I can use either 18 here or I can use 20 here. Okay? Now, 18 is less than 20, but I kind of like 20. Don't you? 20 is a little better than 18. So we're going to take this one, and I'm going to multiply the first one by, let's see, I'm going to multiply by a negative 5, and this one I'm going to multiply by a 4. So that's going to give me negative 30y. That's going to give me plus 20z. And that's going to be a negative 10 over here. This is going to be a 36y, a minus 20z. And this is going to be a 28. 6y, 18, y equals 18. Is that right? Right. Okay. So what would happen if you made a silly mistake like that? Not only do you get y wrong, what else do you get wrong? Okay, at least you'd get z wrong. Okay, and if you use those two and plug back in to figure out what x is, you'd get all three of them wrong. Okay, so do you see how important it is to be really, really careful with your arithmetic? Okay, so y is equal to 3. I'm going to take this and I'm going to plug it back in. I'll plug it into this one right here. So that's going to be 6 times 3 minus 4 times z equals 2. That's 18 minus 4z equals 2. Subtract 18, that's minus 4z equals negative 16. So that means z equals 4. Now, am I done on this problem? Would it be easier to plug the two of these into the first one? What?
How did you get that 9y minus 5z equals 7? I got it equals 5.
This one right here? We put the two of these together. So if here's where this one came from. I multiplied this one by, what's that? Good? Good? Okay. Anything else? Okay. Once I have y and z, I could plug them into this first one, or if you wanted to just do elimination really quickly, we could figure out that x is 1. Either way, it's going to work. So the answer on this problem is 1, 3, 4. There's our ordered triple. So if we were to graph these planes in three-dimensional space, if we have that capability, okay, they would cross at that one single point. Okay, any questions? Sure? All right, let's take a look here because these get a little bit interesting. What's weird about this one?
First one doesn't have an
First one doesn't even have an x. My gosh, we've got one that already has a y plus a 3z equals 4. Well, what are we going to do with equation 2 and 3 then? Put them together. So all I have to do on this one is put them together, and I get a y. I get a 3z, and that equals, let's see, 0 and 1, that's a 1. I then want to eliminate, so I'm going to go through and how about I just do this? What if I multiply this one by a negative? Because that would give me a negative y. Am I going too fast, or are you ready for this? So that would be a minus, that would be a minus, and that would be a minus. This would be, 0, because they all go away, and on this side I get a 3. Now if you see something like that that says 0 equals 3 or 7 equals negative 2, is there any way that's going to be true? It's not going to be true. So if that's not true, if that's never going to be true, then the answer is no solution. Okay? So what does that mean about the planes? Flip your page over. 1, 2, 3, or 4. It's probably 3. Okay, it could be 4 with some further investigation, but it's got to be either 3 or 4. Okay, is it terribly important which it is? No. Okay. All right. Let's take a look at the next example then.
Just because it's only numbers.
You want to do 1 and 2? Yeah.
The equation 1 and equation 3 are the same, just multiplied by 2, so it's not dependence.
Very good. It is. It is. Okay. Nice job. You are correct. Let's everybody else arrive at the same place. Let's go through and let's solve this one right here. Okay. Let's put the two of these together. So if I put 1 and I put 2 together, what do I end up with? I end up with 2 x's, right? I end up with minus a y, no z's, and that equals 5. Okay, I need to make another equation that doesn't have any z's in it. So I'm going to take this equation, 2. Remember, I've got to use a different combination than 1 and 2. So I'm going to take equation 2 and I'm going to multiply it by, well, let's see, I want to get rid of the z, so I'm going to multiply it by 2. Watch. I'm going to write it down just down below. So that's going to be 2x. That's going to be minus 4y.
If you wanted to, could you divide the bottom one by 2?
Sure, you could. It very seldom works out that we can divide, though. Okay. This is going to be minus 2z, and this is going to be a 2. So if I put the two of those together, that's going to give me 4x. That's going to give me minus 2y. And over here, I'm going to have a 10. Any questions? Okay, so if I then eliminate here, I'm going to multiply this by negative 2, so that's negative 4x. Let's see, and this is positive 2y, and this is negative 10, so I end up with 0 equals 0. Okay, well, that's always true, right? It is. So how are we going to solve this? Okay, the key is thinking about what John said. What do you notice about equation 1 and equation 4? What's that? Sorry, equation 1 and equation 3, thanks. They're exactly the same. They're multiples of one another, right? So really, this is a copy of that one right there. So these are the same equations. So this is what we have. We have x plus y plus z equals 4, and we have x minus 2y minus z equals 1. That's all we have. That's it. Okay? So if I were to solve this equation, I can just put those together, right? I get 2x minus y equals 5. So let's see. Can I finish solving that? No, can't finish solving that. Okay. This is 1, 2, 3, or 4. It's not this one, right? It's not these two, because we said it's going to have an infinite number because we've got that 0 equals 0. It's got to be this one right here. Okay. So this is a consistent dependent system. It's consistent and dependent. Okay. And for now, we're going to leave it like that. Okay. Now, are there any questions? Okay. Here's what I'd like to do. Remember, you've got the project to work on. You're working on those in tables. I would like you to log on and at least get started on the homework in Math Excel from this section. I just want to make sure everybody can get started. You can work on it over the weekend. When should it be done? Okay, it should be done on Monday. We're going to review Monday. We're going to review Tuesday. Test is Wednesday. Yeah.
Should we do a project right now?
No, I would log on and do 3.4 because it's due on Monday. Okay. Remember, I'm going to give you a few minutes in class on Tuesday to kind of finalize the project. All right?
I understand it.